Alright, these are some more notes on section 5.6 part 1. In this video, we're going to be multiplying radicals together. Now, just like we did, or like I said in the simplifying radicals video, all we're doing is changing the form. We're changing the way these problems look. We would still get the same answer if we put it in the calculator, the original problem, but we want to simplify it and give the simplest answer we can. So really all we're doing is changing the way that it looks. When we multiply radicals, there's a couple things you should remember. The first thing, if you're going to multiply radicals, they must have the same index. Okay, that little number up the top must be the same for both radicals or all three radicals. Okay, it has to be the same for everything. If you do have a problem where you have three radicals and two of them have the same index, you can go ahead and multiply those together, but you cannot multiply it by the third. So just realize that whatever you're going to multiply together has to have the same index. Now these next three bullet points are the steps. First thing you want to do is simplify your radicals, and we've done that. We did that in the last video. Simplify the radicals first. And then you're going to multiply them together. And when you multiply, you want to multiply things that are in the same place. By places, I'm going to use words outside, which are the numbers out in front of the radical, and then the underneath. Okay, the radicand. Those are the two things that you want to multiply. You want to multiply the numbers that are outside together and the numbers and variables that are underneath and the radicands together. Okay? Once you do that, you want to simplify again. Now, some people don't like to simplify them first. The reason I tell you to simplify the radicals first is so that your numbers are smaller. You don't have to simplify them to begin with. You can go ahead and multiply. You can skip that first bullet point in the steps. The problem is you'll get larger numbers, and if you don't like to deal with larger numbers, you're better off simplifying it first. Okay, so let's look at our examples. We have two examples here. First example is the square root of 18ab times 4 times the square root of 6a squared. Now that's written a little odd. That 4 is out in front. It is not the index, okay? So realize that is my mistake when I wrote the notes. First thing we want to do is we want to simplify the radicals. So let's break down 18. We want the biggest perfect square that goes into 18. It'd be 9 times 2. 9's our perfect square, which means 3 goes out in front. A and B, neither of them have an exponent bigger than the index, so they're both going to stay underneath. So that gives us 3 times the square root of 2ab. Our second radical in this problem, we have 4 times 6. Let's see if we can break down 6. 6 is 2 and 3, but neither of those are perfect squares, so they both stay underneath. A, however, we'll do 2 divided by 2, gives us 1 remainder 0. So we are going to take the A out in front with the 4. And we're just going to leave the 6 underneath. Okay? So that's how we would simplify both of them. And again, we do that to get smaller numbers when we multiply them together. Okay, now we're going to multiply these things in the same place. We're going to multiply the numbers out in front, which are 3 and 4a. 3 times 4a is 12a. And then we're going to multiply the radicands, what's underneath. 2ab times 6 is 12ab. Now we're going to try to simplify this again. Okay? See if we can break anything underneath the radical down. 12. We want to find a perfect square that goes into 12. Well, that's 4 times 3. 4 is a perfect square, so we're going to take a 2 out in front. So now we have 12a times 2. The A and the B, neither of them still have a radical, or an exponent, that's bigger than the index. So they're both going to stay underneath, which means we're going to leave 3ab underneath. Now we multiply these two together out in front, 24a square root 3ab. Now there's one other thing to check for. We can't forget about absolute value signs. We always want to leave that in the back of our mind when we're solving these problems. So we have to check for absolute values. We have an even index, and a, our variable out in front, has an odd exponent, so it does need to be an absolute value sign. So the final answer is the 24 times the absolute value of a times the square root of 3ab. There would be the answer to our problem. Now, again, you can multiply them together right off the bat. You will just have larger numbers. You're going to get the same answer. But it might take you more steps. You'll have bigger numbers to deal with. So it really depends on how you want to solve the problem. All right, let's look at our second example. Our second example is written a little differently. Notice we have the things written in parentheses, and that's fine. It means the same thing. We're just going to multiply them together. Both of them also have an index of 3, which is good. That means we can multiply them. So our problem is the cube root of 4x cubed times the cube root of 10x. We want to try to simplify them first. To break down 4, we only get 2 and 2, neither of which is a perfect cube, so it's going to stay underneath. The x, however, 3 divided by 3 is 1 remainder 0. That means the x is going to go out in front. So the first radical, when simplified, is x times the cube root of 4. The second radical, try to break down 10, 2 and 5, neither is a perfect square, and the x has an index of 1, an exponent of 1, which is smaller than the index, so it's going to stay underneath also. The second radical doesn't simplify at all. Alright, so here's our problem at this point. X times the cube root of 4 times the cube root of 10x. We're going to multiply the things in the same place together. So x is out in front times the 1 that's not written but understood to be out in front of the second one. And then 4 times 10x is 40x. Now we're going to try to simplify this again. We're going to try to break down our 40. 40, we want to find a perfect cube. Well, 40 is really 8 times 5. 8's a perfect cube. It's really 2 cubed. That means that a 2 is going out in front with our x. The 5 is going to stay underneath. Now this x here, again, its exponent is still smaller than the index, so it's going to stay underneath. So here's what we have so far. 2x times the cube root of 5x. We do not need to check for absolute values on this one because our index was odd to begin with. So there's the answer. We've simplified it. And that's how you multiply radicals. If you have any questions, watch the video again or bring them to class next time.